Hey friends, today I am talking about line segments and the distance formula with Pythagorean Theorem. So the first thing I need you to do is grab some graph paper and pause the video, or you might need to restart because you need graph paper to graph these 2 points. They give you the ordered pair 3, 0, which is right here, and 7, negative 5, which is right here. So we are looking for the distance between these 2 points. How can we find it? Well, we can use the Pythagorean theorem. We can figure out that this length and this length are going to form a triangle. And the lengths of each of those legs are 5 and 4 respectively. So we're trying to find this right here, which is our C. So let's plug it in the Pythagorean theorem. So 5 squared plus 4 squared equals C squared. So we get 25 plus 16 equaling C squared. So put 25 plus 16 equals 41 in your calculator, and then we're going to use the square root button, and we get 6 and 4, 0, 3, 1, 2, so we have to round that. So we're just going to round to the nearest hundredth, and we get 6 and 40 hundredths, but we don't even need that, so just 4 tenths, because the 3 tells the 0 to stay the same. What if we don't have graph paper? Sometimes that's inconvenient. We're going to look at the distance formula to help us with this. So take a second and copy down this formula for me in your notebook. Title it Distance Formula. This formula is going to allow you to find the distance between 2 points without having to graph it. So we're going to take the distance formula, as you see here, and we are going to plug in our 2 points. Well, we know this is x and this is y, so let's label this x1 and y1, not 2, just kidding. And then this one x2 and y2, and put them in respectively. Now all that's left to do is simplify. 7 minus 3 is 4, square it. Negative 5 minus 0 is negative 5, square it. We get 16 and 25, which look oddly familiar from our Pythagorean theorem formula before. And if we add them together, we get 41, again an oddly familiar number, and we are going to find the square root of that. So D, again, equals 6 point, what was it? 4. Thank you, Ginger, my helper. All right, and these are units because we don't have feet or inches or any of that good stuff. Let's try one on our own, okay? So take a second, graph the ordered pair for me, find your line segments, and use the Pythagorean theorem. Then when you're done with that, I want you to try to use the distance formula as well to reinforce that. So another graphing and then another distance formula, and I'll be back in just a second to show you what I did. Okay, so here we go. Let's first graph the ordered pairs. So when we make our triangle, we've got 1 and 3 as the side lengths, and then we don't know C. So 1 squared plus 3 squared is really 10, equaling C squared. And when we find the square root, we're going to square the 10, and we get 3.162. Okay, so we see that our 6 and our 2, the 2 tells the 6 to stay the same, so 3.16. So C equals 3 and 16 hundredths, and these are, we don't know, so let's label them units. If we use the distance formula, let's plug in the numbers, and as you went through, you should have seen some oddly familiar things like this 9 and the 1, because those were your A and B squareds, and so D equals 10 squared, or excuse me, 10, the square root of 10, which is 3, and my helper Ginger says 16 hundredths is what she got on both of them, and those are in units. So that's all I've got for you today, and I will see you next time. Ginger, say bye.